Guys, welcome to today's training session. So on this episode, we are going to we are going to delve into how to estimate soil erosion using universal soil loss equation model in ArcGIS Pro. So before we start, we have to um, talk a bit about the universal soil loss equation. So as you can see, USLE estimates the long-term average annual rate of erosion on a field slope based on rainfall pattern, soil type, topography, crop system, and management practice. So as you can see the formula for the definition, we have A representing average annual soil loss, R for rainfall erosivity, the K is the soil erodibility factor, LS is the topographic factor, C is the cropping management factors, P is the practice support factor. So as you can see the formula, these are the components that we are going to use to calculate for the average annual soil loss. So let's start with the first component, which is the rainfall. So about the rainfall, we have to talk a bit about it. So the rainfall is the kinetic energy of raindrops impact and the rate of associated runoff. So to prepare its layer in the ArcGIS Pro, we are going to use the global rainfall erosivity data, which is the global data set. So let's go straight to ArcGIS Pro. So this is my ArcGIS Pro. First of all, I have to go to catalog and add my and connect my folder. So you come here, you right click, you click on the add folder connection. So this is where my data is. So I click on it and I add. Yeah, we then come to the folders soil erosion project folder. First of all, add our global rainfall data. Yeah, so you can click on it twice, double click, or you can drag it into the map. So after doing that, you are going to get this result. Yeah, you get this my rainfall global rainfall data. Yeah. So after getting this global rainfall data, the next thing is to add my area of interest, which is the district I'm going to use for the project. I come to my country shapefiles, then this is my district. I click on district, then I pull it. So let me zoom to layer for you to see it well. Yeah, so I can change the symbology. To this for it to be visible enough. Yeah. Yeah. So we then extract the raster within. We then select. We then select by attribute our area of interest. So we go to map, select by attribute. So this is the expression where district is equal to district over here. Then I choose my area of interest, which is Agona Then I click on apply, then OK. So after doing that, this is what I'm going to get. And change and zoom to layer. So we can now remove the full district data. Good. So our next thing is to extract the raster within the area of interest. So we are going to use the geoprocessing tools. So we go to tools, then you can type the extract by mask over here. Yeah, so the input raster, you choose the global rainfall data, and the feature mask data, you choose the area of interest. Then you can give it the name you want. Then you extract, you run, click on the run. After clicking on the run, this is the result you are going to get. Yes. So you can symbolize this. You can symbolize it to the, you can symbolize this one to the color scheme you want. You can now uncheck the global rainfall data. So we've gotten the rainfall, the the rainfall erosivity now. So the next thing we have to do is to add our soil data. So we go to the catalog, then we come to this side, then I drag it to this map. So let me uncheck this. So when I drag it here, this will be my soil my soil map. So this is my soil data. So the next thing we have to do is to extract the raster within the area of interest. So we go to the geoprocessing tool, we go to extract by mask. The same process we did for the rainfall erosivity, we choose the soil data, which is this one. Then you choose the area of interest, so the area district. Then you click on run. After doing that, this is the result you are going to get. Let me zoom to layer. Yeah. So this is the actual results you are going to get for the soil erodibility. Soil erodibility. Yeah. So you can symbolize, you can change this to any color scheme you want, your preferred color scheme. After getting this, we have to go to our MS Access data to check for the mapping unit and its component. Here. So we use the harmonized world soil database. And this is where I downloaded my soil data, which is the HWSD raster zip, and I downloaded the HWSD soil attribute database, which has the metadata information for my mapping unit. So as you can see, we only had one mapping unit at this particular district. We only have one mapping unit. So let's find this mapping unit on the MS Access table. So this is my MS Access database. We go to HWSD data, click on it, then we go to search. I search for my mapping unit 1046 and click on find list because we already have it. So this is the information, the metadata information about the mapping unit. So the next thing to do is to copy the information and put it in an Excel sheet. Yeah. For here, we only need 4 information to calculate for the soil erodibility, which is the sand, the silt, the clay, and the organic carbon. Our next move is there's one thing we have to do to calculate for the organic material, and from the organic material we can get our textural class, and then finally get our K. So we go to the rules 1996 table. Yeah. So this estimating soil erodibility K based on soil texture and organic material content. So we have the textural class, we have the Spanish texture class, we have the soil composition, the mean K based on organic material. So the soil composition, as you can see on the table, we have the sand, silt, clay. So we are going to calculate for our organic material using this formula 1.72 times organic carbon times our organic carbon. So first of all, let's go to the Excel sheet to calculate for the organic material. So when we come here, we have the constant 1.72 times the organic carbon, which is 2. Which is 2.02. We click on enter. Then we have 3.4744 for the organic material. So let's use this value to compare the organic, the mean K here. So first of all, we check the value for sand, which is 86. Value for sand, which is 86. So when we come here, we can sand 86. This is it, between 86 and 100. So we choose this one, 86. Then let's compare the silt to see whether they are going to fall into 0 to 14. So silt is 8 and clay is 6. Silt is 8, clay 6. So sand is 86, silt is 8, so it falls within 0 to 14. Clay is 6, so it falls within 0 to 10. Then we have our organic material to be 3.47. So the 3.47, is it less than 2% or greater or equal to 2%? So it's greater or equal to 2%, greater than 2%. So we are choosing 0.01. Now we can see our textural class is sand. Sand. And K is 0.001. So 0.01. Yeah, so now we have our value for the soil erodibility. So let's go to our ArcGIS Pro. So we have to input the K value to the mapping unit over here. For us to do that, the only process, we have several processes, but we used the raster to polygon process. So we have to convert our raster data to polygon before we can add any field to the attribute table. Okay, so let's go to geoprocessing tool, go to raster to polygon, input raster, we choose the extract soil. Okay, the field, we leave it as the value. Then we click on run. When we click on run, the result we are going to get is raster extract. So then, yeah, so this is it. So we get a raster extract. Now we can add another field to the attribute table in order to input the K value. Let's go to attribute table. So we can see the shape polygon ID1, grid code. You can see 1046, shape length, and other stuff. We already have 0.01 here, but originally it's supposed to be now. So let me show you how I did it. Add field. So you come here, you add this field, this particular field to the table. So you type K, you choose double over here, can edit it. You choose double over here. Then after everything, you click on save. Click on save. Click on save. Then you come back to your raster. It's not supposed to be there. Just a mistake. Yeah. So when you add the K, then you come here, you edit this actual space, then you type your value over there, which is the 0. You type the 0.01 value here. Then you come here, edit. This one will be highlighted whenever you do any editing. So you click on save, and you close the attribute table. The next thing for you to do is to convert this back to the raster. So you go to the geoprocessing tool, go to, this time we are doing polygon to raster, to raster. Polygon to raster. So we choose the raster extract, and the value field. Note the value field, we change the object ID to what you added to the field, which is the K. You change it to K, then you run it. So after running, we are going to get this result. We are going to get this result, and you can change the color scheme, which is symbolize it any way you want. Yeah. Yeah. So I think this is the first part. So now we have we have the rainfall, erosivity, we have the soil erodibility. We are yet to calculate for the other components. Thank you very much for this episode. We entreat you all to subscribe to the channel and get exciting but entertainment, exciting but educative videos in our next